So if you crush a heavy leg day, and you immediately strap a frozen bag of peas to your throbbing hamstrings, you might actually be delaying your own recovery.
Oh, yeah. Big time.
Right. Because we've been told for decades, I mean, literally forever, to just ice it and rest. But what if the secret to waking up without that crippling soreness isn't just about making the tissue cold, but like simultaneously crushing it with calculated mechanical pressure?
Yeah, the standard advice has definitely created, a diagnostic blind spot for a lot of people.
Mm-hmm.
We treat muscle fatigue like this simple math equation, right? Like work minus rest equals recovery.
Exactly.
But the biological reality of how a muscle clears metabolic waste and rebuilds its contractile strength, it's incredibly dynamic. I mean, it requires specific environmental triggers that a simple bag of ice on the couch, just cannot provide.
Which brings us to our mission for this deep dive. Today, we are exploring the absolute cutting-edge science of muscle recovery.
Yeah, it's a great topic.
We're going to answer the big questions for you guys, like, do high-tech targeted recovery tools actually accelerate healing on a microscopic level? And critically, does that technology work differently depending on your age and your baseline fitness level?
It is an essential line of inquiry, honestly. The fitness industry tends to market recovery tools as this universal magic bullet.
Oh, totally. One size fits all.
Right. Treating every single human body as if it responds to physical stress on the exact same timeline. But I mean, the cellular machinery of a 20-year-old and a 50-year-old, they operate under very, very different physiological constraints.
Completely. So to get to the bottom of this, we're drawing on a really fascinating 2026 study from the Journal of Sports Science and Medicine.
Excellent paper.
Yeah, it's a team of researchers. Let me get all the names here. Led by Robert Trybulski, along with Adrian Kużdżał, Gracjan Olaniszyn, Filipe Silva, Filipe Manuel Clemente, and Wang Hsing-Kuo. They published an article titled Acute Impact of Cold Compression Therapy Across Diverse Age Groups and Physical Conditioning Status. A randomized crossover study.
It's a mouthful, but...
It is a mouthful, but okay, let's unpack this. We have all felt that brutal post-workout ache, right?
Oh, yeah.
You overdo it, and the next morning you are literally walking down the stairs sideways.
It's the worst.
Right. But this study looks at a clinical method to hack that recovery process using a highly specific mechanized combination of cold and pressure.
And what's fascinating here is that, while cold and compression therapies are pretty standard in sports medicine, I mean, they are crucial to sustain adaptation and reduce cumulative load effects. This particular study is really groundbreaking in its design.
Yeah, the setup is wild.
It's a multi-center, randomized crossover trial.
Yeah.
Which is, the gold standard for clinical research because the participants act as their own controls.
Right.
But what makes it truly unique is that it tests a highly specific protocol across 3 drastically different populations, all at the exact same time.
Giving us this comparative map of human recovery.
Exactly.
So let's get right into how they built that map. Because if you want to measure how well someone recovers, you first have to systematically damage their muscles.
Right. You have to break them down.
You have to engineer fatigue in a very controlled, identical way across all your subjects. Otherwise, I mean, the data is useless. One person's exhausted is a professional athlete's warm-up.
Exactly. You have to establish a baseline of severe, localized tissue trauma. Because without a level playing field of pain, basically, the subsequent measurements of healing are completely meaningless.
So they recruited 80 participants in total, dividing them into 3 fascinating cohorts. First, you have 40 elite mixed martial arts athletes.
Wow.
Right. Professional fighters with at least 5 years of intense, continuous training. Then you have 20 healthy young adults, aged 20 to 24, and finally 20 physically active older adults all over the age of 50.
It is a brilliant cross-section of human capability.
Yeah.
Where you have the absolute pinnacle of mechanical conditioning in those MMA fighters.
Yeah.
You have baseline youthful resilience in the 20-somethings, and you have aging biology all participating in the exact same protocol.
And to exhaust all 80 of these people identically, the researchers use something called the Nordic hamstring exercise.
Oh, man.
Yeah, if you're listening and you have never seen one of these, let me paint a picture. You kneel on a padded board, someone physically anchors your ankles to the floor, and you have to keep your body completely rigid-like from your knees to your head.
Like a board.
Like a board. Then you slowly lean forward toward the ground, and you have to use only your hamstrings to resist gravity for as long as possible until the muscle just gives out and you catch yourself with your hand.
Which is incredibly hard.
Oh, it's brutal. And they made all 80 participants do 3 sets of this to absolute volitional exhaustion.
Right. And volitional exhaustion is just a clinical way of saying they worked them until complete structural failure.
Mm-hmm.
The participants literally could not execute a controlled descent for 2 consecutive reps.
You know, I was reading this methodology and thinking, it sounds like slowly lowering a heavy medieval drawbridge.
That is a great visual.
Right, but instead of using the mechanical crank, you're just holding the winch with your bare hands, feeling the tension build until the gears just completely shear off.
Yeah.
It is an incredibly intense eccentric load on the hamstring. But I do have to push back on the researchers a little bit here. Like, is this actually an accurate reflection of normal sports fatigue for you and me?
Yeah.
Or is this just an isolated torture device they built for the laboratory to guarantee everyone was in agony?
Well, I mean, it looks illegal, sure, but it's actually incredibly deliberate and highly ecologically valid. Oh, yeah. In sports, and even just in daily life, catastrophic muscle injuries rarely happen when a muscle is contracting and shortening like at the top of a bicep curl.
Okay, yeah.
Injuries happen when the muscle is forced to lengthen while under immense load. Think about sprinting down a field or throwing a heavy kick or rapidly changing direction on a tennis court. Your hamstrings are constantly acting as the brakes for your body weight.
Right, they're catching you.
Exactly. That braking motion is an eccentric contraction.
So they are purposefully simulating the exact type of stress that causes the microscopic tearing associated with hamstring strains.
Precisely. They had to recreate the exact mechanism of structural failure. When a muscle is forced to lengthen while trying to contract, the microscopic proteins inside the muscle fibers, the actin and myosin, they're physically ripped apart.
Ouch.
Yeah, it is sheer structural trauma. And we know the protocol worked flawlessly. The researchers measured the participants' maximal voluntary contraction, which is basically their absolute peak strength, using a handheld dynamometer right after the exercise.
And what happened?
The mean peak strength decreased by about 25% in the elite MMA athletes, and it plummeted by up to 35% in the older adults.
Wow. So they completely destroyed that drawbridge winch across the board.
Yep.
So we now have 80 people with absolutely wrecked hamstrings. What is the immediate biological priority to fix that? Because just sitting on the couch waiting for the body to heal itself clearly isn't enough for a professional athlete or, for an older adult who just wants to be able to walk comfortably the next day.
Right. So the immediate priority is managing the chaotic inflammatory response and clearing out all the metabolic garbage left behind by that trauma.
Okay.
And that is where the intervention comes in.
Right. And the researchers didn't just tell them to go rest. They immediately deployed the freeze and squeeze. They used this clinical device called the Med4 Elite.
Yeah.
It's a professional software-controlled pneumatic cold compression unit. And what blew my mind is that it's totally iceless.
Yeah, that's the cool part.
It uses an internal refrigeration system to pump fluid and air through these dual-chamber anatomical wraps that go all the way around both thighs.
And the dosing of that fluid and air is the critical variable here. They didn't just wrap the legs and turn the machine on at random.
Right. The active treatment group, what the paper calls the CC group, got a highly specific dose. The unit was set to deliver 3 degrees Celsius cold.
Which is violently cold.
Yeah, just a hair above the freezing point of water. And simultaneously, it applied high intermittent compression, reaching about 75 millimeters of mercury in pressure. They did this for exactly 10 minutes, twice a day, for 3 consecutive days.
That's a serious protocol.
Yeah. Meanwhile, the sham group, which served as the control, they got the wraps too. But their wraps stayed at a mild 15 degrees Celsius and provided barely any pressure, just 15 millimeters of mercury.
And the sham is essential in a trial like this. It mimics the sensation of being hooked up to a fancy clinical device, keeping the participants blinded to whether they're getting the real mechanophysiological intervention.
Yeah. Now, I know what you're thinking listening at home, because I thought the exact same thing when I first read the setup. Why go through all this trouble with a $5,000 digital AC-powered dual-chamber robot wrap?
Right.
Why not just strap a bag of frozen peas to your leg and wrap an ACE bandage around it really tightly? Like, isn't cold just cold and pressure just pressure?
Well, if we connect this to the bigger picture, we can see exactly why the bag of peas falls completely short.
Okay, tell me.
The goal isn't just to make the surface of your skin feel cold. The goal is to deliver a dynamic mechanothermal stimulus deep into the muscle belly.
Mechanothermal, so mechanical pressure combined with thermal regulation.
Exactly. Consider the mechanism of the Med4 Elite. It features automated duty cycles. So it doesn't just squeeze your leg once and hold it there like a static elastic bandage.
Right.
It provides a rhythmic, sequential inflation and deflation. This dynamic pumping action physically massages the tissue.
Oh, I see.
So when you combine that aggressive milking action with fluid constantly circulating at 3 degrees, you are forcing a modulation of blood flow. You are driving deep tissue temperatures down while simultaneously pumping stagnant fluid out of the damaged area.
Whereas static ice?
Static ice warms up against your skin within minutes,
Yeah.
and a static bandage just traps fluid. The machine forces a continuous exchange.
Wow. So a bag of peas is completely passive. You're just hoping the cold sinks in.
Pretty much.
But the machine is an active, aggressive intervention, forcing the tissue to respond.
Exactly.
So with the exact dose of cold and pressure established, let's look at the physiological outcomes. Did this highly specific technology actually accelerate tissue repair over the 48-hour observation window?
Well, the data is definitive.
Yeah.
Yes, it's a significantly accelerated recovery across the board compared to the sham group.
That's awesome.
It really is. But to understand the true value of this study, we have to look at the specific metrics they tracked to see exactly how it worked.
Let's run through those key findings. First, the participants who received the active cold compression had significantly higher maximal voluntary contraction. So their baseline strength simply came back faster. They also had higher pressure pain thresholds. The resetters basically pushed a blunt probe into the muscle, and the active treatment group could tolerate significantly more physical pressure before they registered pain.
Yeah, so the inflammatory markers were clearly blunted. But the researchers went deeper than just asking about pain. They used myotonometry to measure muscle stiffness.
Oh, let's explain myotonometry for the listener because it sounds like science fiction.
It kind of is.
It's essentially this highly sensitive mechanical probe that gently taps the surface of the muscle and records the tissue's mechanical oscillation.
Right.
It tells you exactly how stiff or pliable the muscle fibers are, completely independently of how the participant actually feels.
Which is crucial because it removes the placebo effect entirely. And the myotonometry proved that the cold compression group maintained far more pliability in their hamstrings. Add to that the laser Doppler flowmetry data.
Firing a tiny laser into the tissue to track the movement of red blood cells, which is so cool.
Very cool. By measuring how the laser light bounces off moving blood cells, they can calculate the microvascular perfusion. That's the actual volume of blood flowing through the tiny capillaries in the muscle.
Okay.
And the active cold compression forcefully kept that local circulatory function higher than the control group.
Okay, here's where it gets really interesting. Let's talk about the blood lactate level.
Oh, yes.
When your muscles work to absolute failure, they build up metabolic byproducts. Lactate is a major one, creating an acidic environment in the tissue. And the data showed that the blood lactate levels only dropped significantly compared to the sham group immediately after the very first 10-minute treatment session.
Right.
They call this time point T2. In the later measurements, like at 24 and 48 hours, the lactate levels between the active group and the control group were basically identical. It was a one-time, immediate flush.
And that T2 measurement is really the skeleton key to understanding the entire therapy.
How so?
Think of the damaged muscle like a severely clogged pipe in your house. The heavy eccentric exercise shoved a massive blockage of metabolic debris into the plumbing.
Okay.
The pneumatic compression acts like a heavy-duty chemical drain cleaner. You pour it down, and it forcibly flushes the entire blockage out immediately. You don't need to clear the blockage 5 times right.
Oh, I get it.
Once that initial massive flush happens at T2, the pipe is clear.
So the regular water, like the normal natural repair processes of the body, can finally flow freely.
Exactly. The dynamic milking action of the wraps simply hastens the metabolite washout. By rapidly clearing that acidic lactate environment right after the fatigue protocol, improving the microvascular blood supply, and simultaneously reducing passive muscle tension, the cold compression creates a highly favorable biological environment.
So it's not actually fixing the damage itself?
No, the machine isn't magically rebuilding the torn actin and myosin fibers. It is optimizing the construction site so the body's own repair crew can work at maximum efficiency over the next 2 days.
It aggressively sets the stage for healing.
Yes.
Now, this is where we really have to look much closer at the data. Because the overall benefits of the treatment were crystal clear, but the numbers reveal a much deeper story when you break them down by age and training status.
Absolutely. The physiological timeline of human recovery is absolutely not universal.
Right. Remember, we have the elite MMA athletes, the young adults and the older adults over 50. And the timeline discrepancy here is fascinating. For the MMA athletes and the 20-something young adults, they saw the benefits almost immediately. Right at that T2 time point, immediately after the first session, their strength metrics and their blood flow were already separating favorably from the sham group.
Yeah.
But the older adults, they didn't see statistically significant separation from their control group until a full 24 hours later at time point T3.
The older cohort's physiological response was delayed by an entire day.
Which makes me want to ask directly on behalf of our listeners, does this mean the treatment is just inherently less effective if you are, say, a 55-year-old? Or does the biology of aging just require more patience before the benefits show up?
It's a great point.
Because if I'm over 50 and I'm dropping serious money on clinical recovery tools, I want to know if my body can even utilize them.
Right, and this raises an important question about how aging impacts our microbiology. The treatment is not less effective, but the physiological machinery simply takes longer to spool up. As we age, we experience motor unit remodeling. But more importantly, our vascular system physically ages. We lose capillary density, and the blood vessels themselves lose their elastic reactivity.
They can't dilate and constrict as quickly to pump out the bad stuff and bring in the good stuff.
Exactly. They suffer from sluggish microcirculatory adaptation. So the neurological signals demanding repair, they just take longer to translate into physical blood flow. But here is the critical mechanism of how the older adults eventually catch up.
Oh, they do catch up.
Yes. Because their natural vascular elasticity is compromised, the external pneumatic pressure of the Med4 Elite essentially acts as an artificial heart for the local muscle. It forcibly milks the tissue, overcoming that age-related venous pooling.
So the external machine is doing the pumping work that the aging blood vessels struggle to do on their own.
Yes.
It optimizes the environment, but the internal construction workers are just driving a little slower to the job site.
That delay is purely biological. But the data clearly shows that by the 48-hour mark, the older adults had achieved comparable, highly significant improvements relative to their own baseline, basically matching the trajectory of the younger groups.
That's awesome.
The therapy absolutely worked. It just followed a stretched-out timeline.
That is incredibly reassuring, but there is a huge, sobering caveat in this paper that we really need to highlight.
Yes, there is.
Because I think people assume that if you have elite professional genetics, or if you use an expensive clinical device, you just bounce back to 100% overnight.
Well, the fitness industry really sells the myth of the quick fix.
Right.
But the objective data from this study completely shatters it.
Yeah. Because even with this advanced pneumatic intervention happening twice a day, nobody achieved 100% full mechanical recovery by 48 hours.
No.
Nobody. Not the resilient 20-somethings, and not even the elite professional MMA fighters who literally train their bodies to absorb and recover from trauma for a living. The cold compression significantly improved the trajectory of their recovery. I mean, they were vastly better off than the sham group, but it didn't magically erase the fatigue.
We have to respect the scientific reality of structural damage. Look at the MMA athletes. With the active treatment, their strength returned to about 96% of baseline by 48 hours.
Which is phenomenal.
It is phenomenal.
Oh.
But their muscle stiffness, that passive mechanical tension measured by the laser probe, it remained 18% above baseline.
Wow.
They were strong, but their tissues were still physically stiff and structurally compromised.
And for the older adults, the reality check is even starker. Even with the absolute best treatment, their strength was only back to 69% of their baseline at the 48-hour mark.
59%, 2 full days later.
Yeah.
The clinical treatment is an accelerator, but it is not a time machine. Biological healing requires cellular turnover, and that just requires time. You cannot entirely bypass the physiological toll of severe eccentric tissue damage, no matter how much pressure you apply.
So what does this all mean for you listening right now? Let's make this practical.
Let's do it.
Whether you are a competitive athlete gearing up for a tournament or someone over 50 just trying to stay active and healthy, pneumatic cold compression offers a scientifically validated non-pharmacological way to accelerate your strength recovery.
Absolutely.
It manages your post-workout pain, it acts as a chemical drain cleaner to flush the acidic lactate from your system, and it gets you back on your feet significantly faster than doing nothing.
It undeniably optimizes your recovery window by acting as an external circulatory pump.
But you have to calibrate your expectations to your biology. If you are over 50, expect a 24-hour delay before you physically feel the benefits of your recovery protocol. And more importantly, let's look at that 69% strength stat. If you are over 50 and you do a heavy eccentric leg workout on Monday, this data scientifically proves your body is still structurally compromised on Wednesday, even if you feel okay.
Yep.
You shouldn't be scheduling another heavy leg day until Thursday at the absolute earliest.
You really have to respect the biological process. Use the technology to support the healing environment, absolutely, but not as an excuse to replace necessary rest.
If you want to dive into the specific myotonometry numbers or read exactly how they utilize the laser Doppler flowmetry data to track red blood cells, I strongly encourage you to track down the full article.
It's a great read.
Again, it is titled Acute Impact of Cold Compression Therapy Across Diverse Age Groups and Physical Conditioning Status, authored by Trybulski and colleagues and published in the Journal of Sports Science and Medicine in 2026. It is an incredibly thorough look at human physiology.
For sure.
And while you're at it, please make sure you follow our channel and turn on notifications so you never miss one of our scientific deep dives.
It really is a phenomenal piece of literature that forces us to look objectively at how we treat our bodies.
And before we wrap up, we always like to leave you with a little something extra to chew on.
Yeah, consider this. The study demonstrated that despite using state-of-the-art cold compression twice a day, hamstring stiffness remained elevated above baseline at 48 hours across every single group. If even professional fighters using advanced clinical technology aren't fully healed in 2 days, how might we need to radically rethink the standard 1 or 2 rest days we automatically schedule for our own routine workouts?